Srikal students, today we are going to discuss the criteria for similarity of triangles. So, two triangles are similar if their corresponding angles are equal. This is the first condition. What their corresponding angles are equal. Now we will just understand what is the meaning of corresponding angles. See these triangles A, B, C, and D, E, F. Here, corresponding angle of A is angle D, and corresponding angle of B is angle E, and corresponding angle of C is angle F. So we can say triangle ABC is similar to triangle DEF. It's very important, students, to see the second criteria also. Their corresponding sides are in the same ratio or proportion. What is the meaning of this? Now, what are the corresponding sides? AB and DE are corresponding sides. AC and DF are corresponding sides. BC and EF are also corresponding sides. Now, see students, when I say that triangle is similar to this triangle, how I write? I use this sign. I use this sign. This is known as, this sign is sign of similarity. So I will say that triangle ABC is similar to triangle A is corresponding to D. A is in first place, so its corresponding angle D should also be in first place. Then after A I am choosing B. Now corresponding angle of B should be E. If B is in second place here, then E should also be in second place, and obviously the remaining angle is DEF. Right? Students, here correct correspondence of vertices is very important. Let us see what is the meaning of this. What is a vertex? So what are the vertex? What is a vertex? It is a point where two sides meet. That point where two sides meet is known as vertex of a triangle. So what are the vertex? Vertex is single and plural is vertices. So obviously in triangle ABC, A, B and C, these 3 points are the vertices. So vertices are basically points, right? Similarly here in this triangle DEF, D, then E, then F, 3 vertices are there. What is the meaning of correct correspondence of vertices? It's very important. Correct correspondence of vertices only means if after A there is B and after B there is C. Here also after D it should be E, not F, and after E there should be F. Students, now it's worthwhile to note that triangle ABC and triangle A, now instead of taking B, E's corresponding angle E, I take F. A, F, E. These triangles are not similar. It is worthwhile to note, students. Similarly, triangle, change the order of vertices. If you say C, A, B, triangle CAB is similar to triangle. Instead of C, if you write F, it's correct. A, instead of A, you write D. It's correct. FDE. This is right. This is correct correspondence of vertices. But if you say triangle CAB and here you write triangle, maybe you write EFD. So these two triangles are not similar. You might end up saying that triangle is same. No, but correct correspondence of vertices is very important. Because if we write correct correspondence of vertices, see the advantage we get. I'm going to tell you what is the advantage. So students here, let's say I write correctly that triangle, one second, triangle ABC is corresponding to triangle DEF. Well, this is correct. Now, you see other criteria that their corresponding sides are in the same ratio. When the vertices are written in the correct correspondence, then it is very easy to prove this thing. I'll tell you how. He says the corresponding sides in the same ratio. What is the meaning of this? It means AB divided by AE is equal to AC divided by DE is equal to BC divided by EF. So now I need not see the triangle and write. I can even write from here. See, here I get AB. So AB divided by, see from here, DE is equal to what? BC divided by EF is equal to, now go for AC, first and last. AC divided by first and last, DF. So what I wanted to understand by seeing the triangles, I can write even without seeing the triangle if the vertices are written in the correct correspondence. Very important, correct order. So now students, let me understand deeply what is the meaning of that the corresponding sides are in the same ratio. Okay, I want to understand the meaning of this. So students, for this, what we do, we will construct two triangles. We will construct two triangles. Okay, so let's say you take AB as 2 centimeter, right? Here you take CD. What do you do with this compass and scale? Let's say you take double of this, 4 centimeter. Okay. Now here, let's say you draw a angle of 60 degree. Okay. With your D or with your compass, you know how to draw angle of 60 degree on vertex A. Similarly, because if two triangles are same, if two triangles are to be similar, their corresponding angles should be same. The first criteria. So angle A's corresponding angle is angle C. So C should also be 60 degree, right? I will again do this construction. I will write 60 degree. And here, let us say you draw a angle of, let's say you draw a angle of 40 degree. Triangle of 40 degree. Now here also from D you draw a angle of 40 degree. Now these two lines will meet, let's say at C, and here their line, let's say they are meeting at P. Okay, so I can say here, see if these two angles are 60 and 40, 60 and 40, obviously this angle will also be same. So all the corresponding angles, angle C's corresponding angle is P, angle B's corresponding angle is D, and angle A's corresponding angle is angle C. All the corresponding angles are same. I can say two triangles are same, but how? How will I write the vertices? Let's say I end up writing from B. So let's say I say B, C, A. I can write this name of this triangle anyway. Triangle ACB, triangle BCA, or triangle ABC. Fine. Now this should be similar to, now how will you write? See, where is the position of corresponding angle of B? So corresponding angle of B is D. Write D here. Then C, write, sorry, this is D, then B. So instead of A, right angle C. Now I told you, the, sorry, if the triangles, if the vertices of triangles are written in the correct sequence, now what is the advantage you are getting? See, BC, see, I'm not looking at the triangles. BC by DP should be equal to CA by
By P.
BC. Very good. Should be equal to, now if I take AB,
AB by
or,
CD.
oh beautiful, AB by CD. That's great. Okay. Now student, this, no, I know, can I check it? BC by DP. Where is BC? This one. BC and DP are corresponding. I got it correctly. CA by PC. CA by PC. Yes, these are corresponding sides. Then AB, base of the triangle, and CD is also base by base is equal to, you can say, left side by left side is equal to right side by right side. These are corresponding sides. But I have something more to tell you. What is that something more? So students, now what you do, we are doing an experiment. What you can learn from experiment, you can never learn from teacher or from books. Experiment is a better teacher. Okay, so always try to do hands-on experiment. So what is experiment we are going to do? Anything you do with your hands or with your knowledge, and you do some measurement with your hands, is experiment. So now students, AB was to, what is AB by CD ratio? AB by CD, this ratio is 2 by 4, that is equal to 1 by, now ratio of AB and CD is 1 by 2. Students, very interesting. Now I can't measure here because I'm not using scale. I want to teach you. You should use scale today, and you should draw the same angles, exactly same angles. Take AB as 2, CD as 4. I don't know what will be AC. I don't know. You will get by measurement, but I am very sure if AC is X, can any student tell me what will be PC?
2x.
Beautiful. I'm so happy. You're right. So this will be 2x. This is experiment you should do, students. Suppose BC is Y, then PD should be
2y.
2y.
2y. Why? Because students, you see, the relationship between the base of bigger triangle and the base of smaller triangle is twice. This is the relationship. Twice means into 2. So the relationship between other corresponding sides will also be what? Twice into 2. So if CB is Y, PD will be 2Y, and I've already explained with this side. So this is exactly, students, the meaning of that in similar triangles. These are similar triangles, angle BCA and angle DPC, or you can say angle CAB, a triangle CAB, and triangle PCD are similar triangles, or you can say triangle ACB or triangle CPD are similar triangles. Start from anywhere, end anywhere, but make sure if you start from B, you should start from B, not B or C. If you start from C, you must start from P, not C or D. So this is about similarity of triangles. Students, if in two triangles the corresponding angles are equal, automatically their corresponding sides will also be in the same ratio. Or if the corresponding sides of two similar triangles are in the same ratio, automatically students, their corresponding angles will also be, tell me students, their corresponding angles will also be
Equal.
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 Equal. Let's say you draw a right angle triangle. Let us say this is 5, this is 3, this is 4. It's a right angle triangle A, B, C, which is right angled at B and which is satisfying all the properties of Pythagoras theorem. You can see that 5 square is equal to 3 square plus 4 square. 16 plus 9. See students, 16 plus 9 under root is equal to under root of 5 square, that is, so here 5 is equal to 5. So let's say you draw another triangle. If you say this base as 2, okay, very small base. 4, here you take base as 2. And if you draw a right angle, I'm just repeating whatever I've said here. If you draw a right angle, and after drawing the right angle, measure this angle. And same angle if you draw here, definitely students, if the relationship between this base BC and this base is again twice, this is double of this. So, or you can say this base is half of this. So this height will also be half of 3, 1.5. This hypotenuse will be half of 5. That will be 2.5. This is very, very interesting, students. Okay. See students, interesting thing, one law will never contradict other law. Contradict मतलब किसी के रास्ते में पत्थर लगाने नहीं. If law of similarity is proven, the Pythagoras law is also proven here. Such an interesting thing. You see here also 2.5 square is equal to 1.5 square plus 2 square. You can say 2.5 square is 6.25. 1.5 square is, students, 15 15s are 2.25 plus 2 2s are 4. What an interesting thing. That is 6.25. Wow. If one law is satisfied, then all other laws stated in mathematics, they will also be satisfied. This is another beauty of mathematics. That's why the brains learn mathematics, and once you are good in mathematics, you will automatically good in the physics also and other related fields of mathematics.